Hi everyone, I am Santhi from Department of Mathematics and Statistics, Bhavans Vivekananda College. I am here with my lesson 25 from linear algebra on vector spaces. In this lesson, I am going to explain about matrix of linear transformation. So, I will explain the procedure to find a matrix of linear transformation and few examples. Till now we were going through what is a linear map or linear transformation. Now we will construct that every linear transformation can give us a matrix. Now let us say what do we mean by matrix of linear transformation. For this I will consider let V and W be two finite dimensional vector spaces with dimension V is equal to n and dimension W is equal to m. And let T from V to W be a linear transformation. So let me go through how it is. I will take this is V and I will take this is W and then T is a linear transformation. These two are vector spaces where T is a linear transformation. Now something else is given here. I have dimension V is equal to n implies there exists a basis for V with n elements. So for that let me take a basis here for V with n elements. So I will take let B is equal to set containing B1, B2 and so on. Bn be a basis for V. So I have here B1, B2 and so on Bn elements. Now not only V is a finite dimensional, we even have that dimension W is also given as n. What do we mean by that? We mean by that is let us take, we can take a basis for W also. So let C is equal to set containing C1, C2 and so on Cm be a basis for W. So I have here this one is C for me now. This is in this what are the elements? I have C1, C2 and so on Cm. So I have this is C basis and this is B basis for V and W respectively. Right. Now I have a linear transformation also. T from V to W is a linear transformation. Implies consider T of B1, T of B2, T of Bn. Where will they be? They will be in W. So why? Because if I have B1, then I will have here T of B1. Where I have B2, I will have here T of B2 and so on. Where I have Bn, I will have here T of Bn. Why? Because T is a linear transformation. Now in W, I have T of B1, T of B2 and so on T of Bn and I have a basis for W also. Right. Now since C is a basis for W, each vector in W is a linear combination of elements in C, that is C1, C2 and so on Cm. Therefore, now where is T of B1? T of B1 belong to W implies T of B1 is equal to R1 C1 plus R2 C2 plus and so on. How many vectors are there in the basis Cm? Rm Cm. Rm That implies I can say what are the coordinate vector? Coordinate vector of T of B1 with respect to the basis C is nothing but R1, R2 and so on Rm. So what did we do here? Since I have a basis here, this is a basis for W and these are vectors in W. So each T of B1 will be a linear combination of C1 to Cm. So I have written that T of B1 as a linear combination of basis vectors, and then if I write like that, then I will get coordinate vector of T of B1 with respect to the basis C. This is the one. Similarly, T of B2 is also a linear combination of C1, C2 and so on Cm. That implies, and let I will take T of B1 is equal to some S1 C1 plus S2 C2 plus and so on plus Sm Cm, which implies the coordinate vector of T, this is T of B2, T of B2 with respect to the basis C is S1, S2 and so on Sn. So what did we do? Again, how we wrote for T of B1 linear combination of C1 to Cm and the coordinate vector, the same way for T of B2 is also a linear combination of C1, C2 and so on Cm, and hence you can get the coordinate vector for T of B2 also. Then how many are there like that? I have T of B1, T of B2 and so on T of Bn. N elements are there. So similar and so on, I can say similarly let T of Bn is equal to, let me take Z1 C1 plus Z2 C2 plus and so on plus Zm Cm. Then the coordinate vector of T of Bn with respect to the basis C will be Z1, Z2 and so on Zm. That therefore we have R1, R2 and so on Rm, comma, S1, S2 and so on Sn and so on Z1, Z2 and so on Zm, coordinate vectors of T of B1, T of B2 and so on T of Bn respectively. Now consider these coordinate vectors as columns, that is as columns for what? Let us say as columns for a matrix. That is, I will take a matrix A. Then what is the first column in this coordinate vector of T of B1? That is R1, R2 and so on Rn. Coordinate vector of T of B1 with respect to C. Then second column is S1, S2 and so on Sn. This is coordinate vector of T of B2 with respect to the basis C. And so on. This is Z1, Z2 and so on Zm. this is M or N. Let us how many are M? Yeah, this is also SM, and then this is also ZM, because how many vectors are there in the basis here? C1, C2, they are M number of vectors in W. So this will be it. M rows. This is coordinate vector of T of B N with respect to the basis B. What will be its order? It will have how many rows? So it will have obviously M columns, and then how many, not M columns, M rows, and then it will have how many columns? N columns, because there are N vectors. These are N vectors. So this will have M rows, because 1, 2 and so on, M rows. This is row 1, row 2 and so on, row N. And this is column 1, column 2 and so on, column N columns. So you will get a matrix. So this we will call it as matrix of linear transformation of T. So this you will write it as it is equal to, you will say like this, matrix of linear transformation T with respect to the basis B and C. B is the basis for the domain and C is the basis for the codomain, and its order will be M by N. This is what coordinate matrix of linear transformation. So I can even define a matrix of linear transformation precisely like this. A matrix of linear transformation is formed by taking the coordinate vectors of T of B1, T of B2 and so on, T of Bn with respect to the basis C of W as columns, and here you have to remember that B is equal to B1, B2 and so on, Bn is a basis for. Thus, a matrix of linear transformation is formed. And you have to remember one note point. If dimension V is equal to N and dimension W is equal to M, T from V to W is a linear transformation, then matrix of linear transformation with respect to basis BC will be A, which has order M by N. Whereas dimension V is N, dimension W is M, but matrix will have the order M by N. This point we have to remember. Now let us look at a problem how to find a matrix of linear transformation. So let B is equal to set containing B1, B2, B3, and D is equal to set containing D1, D2, B basis for V and W respectively. T from V to W is a linear transformation given by T of B1 is equal to 3D1 minus 5D2, and T of B2 is equal to minus D1 plus 6D2, and T of B3 is equal to 4d2. Then find the matrix of linear transformation relative to B and D. Right. Now let us first draw a diagram for this. I have here V and W, and we have a basis for this one is it has elements B1, B2, B3, and then this has a basis with elements D1, D2. Now, according to the procedure, what do we have to do? The procedure says first to find, there is a basis for V is given, there is a basis for W is given, T is a linear transformation, find T of B1, whatever the basis elements in the domain, find T of B2, find T of B3, right. So already this is given, T of B1 is given to you, 3d1 minus 5d2. T of b2 is given to you, minus d1 plus 6d2. T of b3 is also given to you, 4d2. And express this T of b1 as a linear combination of d1, d2. So what is the first step? We have bases are given. So what is the first step is finding T of b1, T of b2, T of b3. Already given in the example. What is our next step? Express them as a linear combination of what is the basis? D1, D2. So that is also already given. It is also given. What is given here? T of B1 is equal to, what is that? 3d1 minus 5d2. It is already given as a linear combination. That is, I can say 3 into d1 plus minus 5 into d2 implies what is the coordinate vector of T of b1 with respect to the basis C is 3 minus 5. So you should pick only the coordinates. Similarly, T of B2. What is T of B2 given to us? T of B2 is given as minus D1 plus 6D2. So it is given as minus D1 plus 6D2. Again this I will write it as minus 1 into D1 plus 6 into D2. That implies the coordinate vector of T of B2 with respect to the basis C is minus 1, 6, and what is T of B3? It is given as 4D2. That is, we will write it as 0 into D1 plus 4 into D2, which implies T of the coordinate vector of T of B3 with respect to the basis C is 0, 4. Now, matrix of linear transformation T with respect to the basis B and C is, first one is coordinate vector of T of B1. What is the coordinate? First column is 3 minus 5. So I will write 3 minus 5. This is nothing but coordinate vector of T of B1 with respect to basis C. And the second one is coordinate vector of T of B2 with respect to the basis C. And the third one is 0, 4. This is coordinate let me write again. 0, 4 with respect to the basis D of this is quantity of B3 with respect to the basis C, that is equal to 3 minus 5 minus 1, 6 and 0, 4. And what is the order of this? It has 2 rows and 3 columns. And see here, dimension of the domain is 3, codomain is 2, and but you will get m rows and n columns. This is a coordinate matrix. So similarly, you can practice one more problem in the same way. Now let us look at this example. Let E is equal to set containing E1, E2, E3 be the standard basis for R3. Let B is equal to set containing B1, B2, B3 be a basis for vector space V. Then let T from R3 to V be a linear transformation with the property that T of x1, x2, x3 is equal to 2x3 minus x2 into B1 minus 2x2 B2 plus x1 plus 3x3 into B3. So here you can observe this linear transformation formula is given as a linear combination of B1, B2, B3 that you have to observe in this problem. Then compute. First point is T of E1, T of E2, T of E3, and the second one compute coordinates of this. What do you mean by this? Coordinate of T of E1 with respect to basis B. Similarly, coordinate of T of E2 with respect to basis B, and coordinate of T of E3 with respect to basis B. And the third point is find the matrix of T relative to the basis E and B. That is, matrix of T relative to the basis, domain basis is E and the codomain basis is B. Now let us work out this problem. So what is given to you here is E is equal to set containing E1, E2, E3. This is standard basis of R3. That implies, so what is standard basis of R3? This is equal to E1 means 1, 0, 0, E2 means 0, 1, 0, and E3 means 0, 0, 1. This is the standard basis. Then now we have to find out first point to find T of E1, T of E2 and T of E3. So T of E1 is equal to T of 1, 0, 0. And what is that formula we have for this one? If this is x1, x2, x3, then by the given this transformation formula, 2x3 minus x2. So I have 2x3, that is 0, minus x2 is also 0, into b1, and then plus, not plus, it is minus 2x2. x2 is, what is x2 value for us here? 2 into 0, b2, plus x1 plus x3. x1 is 1 plus 3 into x3, that is 0, into b3. So which I can say this is equal to this is 0 into b1 plus 0 into b2 plus 1 into 1 into b3. This you give it as one equation 1, you can say. Now finding T of E1. So let us finish these first. Then what is T of E2? Similarly, what is T of E2? That is T of 0, 1, 0. So this is again, here we have x1, x2, x3. This is equal to, so again apply the formula, 2x3 minus x2. 2 into x3 minus x2 is 1 into b1, and then minus 2x2 b2. 2 into 1 b2, and then plus x1 plus 3x3. So this is 0, 0 plus 3 into 0 into b3. This is equal to, I can say, this is my 2 into 0 minus 1. So this is minus 1 into b1 plus, and the next one is minus 2 into b2. So I have here minus 2 into, let me make this b2. This is b2 for me. Okay, fine. Then plus, and the last is 0 anyway. So I have here 0 into b3. So let me take this also as 2, equation 2. Now the third one is t of e3. T of e3 is t of 0, 0, 1. So again, if we go for the formula, 2x3 minus x2, 2 into 1 minus 0 into b1 minus next 2x2 b2, 2 into 0 into b2, and then plus x1 plus 3x3. So x1 is 0 plus 3x3, 3 into 1 into b3. So this will give you 2 into b1, and then plus 0 into b2 plus, this is 3 into b3, and this is equation 3. So for us now finding t of e1, t of e2 and t of e3, first bit is over computing, and now let us go for the second one. Second one is to find coordinate vectors of t of e1 with respect to b, t of e2 coordinate vector with respect to b, and t of e3 coordinate vector with respect to b. Now we have this to find coordinate vector of t of e1 with respect to b. We have to express t of e1 as a linear combination of vectors in b, that is equal to b1, b2, b3. Now 1 implies, in 1 what do you have? Equation 1. Equation 1 we have t of e1 is equal to 0 into b1 plus 0 into b2 plus 1 into b3. 1 implies t of e1 is equal to 0 into b1 plus 0 into b2 plus 1 into b3. That is a linear combination of b1, b2, b3. Therefore, the coordinate vector of t of e1 with respect to basis b is, what are the coordinates? 0, 0, 1. So similarly I can say 2 implies coordinate vector of t of e2 with respect to basis b. Directly I will write here, what do I have in equation 2? So equation 2, t of 0, 1, 0 is expressed in terms as a linear combination of b1, b2, b3. So what are the coordinates? Minus 1, minus 2, 0. So that you will write them in the coordinate vector. Minus 1, minus 2, 0. And and 3 implies coordinate vector of T of E3 with respect to the basis B is, what do you have? Coordinates in 3. You have the coordinates 2, 0 and 3. So it is equal to 2, 0 and 3. So we found the 3 coordinate vectors T of E for T of E1, T of E2 and T of E3 corresponding to the basis B. Now what is our third point? Third point is find the matrix of T relative to the basis E and B. So now we have to write the third one. To find matrix of T relative to the basis E and B. E and B. So it is a matrix with coordinate vectors of T of E1, T of E2, T of E3, that is coordinate vector of T of E1 with respect to B, coordinate vector of T of E2 with respect to B, and coordinate vector of T of E3 with respect to B as columns. That is coordinate vector of T with respect to the basis E with B is equal to, first column is coordinate vector of T of E1 relative to the basis B, that is 0, 0, 1. Second column is coordinate vector of T of E2 with respect to the basis B. It is -1, -2, 0. And the third column is T of E3, coordinate vector of T of E3 with respect to basis B, which is equal to 2, 0, 3. That is 0, 0, 1, -1, -2, 0 and 2, 0, 3. So in this problem we finally found the coordinate vector of T with respect corresponding to the basis E and B.